Okay, I know there's a microphone here. I hate having a microphone in my face, so I'm not going to use it. We're going to talk a little bit about functional programming and JavaScript. Now, the thing that I'm going to tell everybody about just beforehand is this is kind of more of a thought experiment than anything else. There's a lot of good ideas in here, but I wouldn't necessarily advise, hey, doing everything the way that I show it, because there are places where I just took this too far. But it gives me a different way to present JavaScript, because so many people, they only learn JavaScript in association with the browser and just sticking text on the screen and getting data from the screen and whatever. And we're going to do things just a little bit differently here today. Assuming I can get everything to work. All right. So for those of you that don't know me, and I'm assuming that's pretty much everybody in the room, my name is Troy Miles. I've been at this a long time, and I still like it. So, hey, good for me. I'm also an author of a book, and I can safely say now that writing a book is one of the most perilous and arduous journeys I've ever been on. And I like the fact that I did it, and I question my sanity for doing it in the first place, because I could have made way more money doing a side project than writing a book, because I don't know if you know this or not, I don't think anybody reads anymore. Oh, I shouldn't say that. A lot less people read than used to. And even in stuff where I'm so used to, my career began holding 6502 and x86 manuals and going to the pages of the instructions that I wanted. And now everybody just wants to Stack Overflow everything. And I've actually seen people on Stack Overflow yell at the person that gave them the link that has the answer to the question that they had, because they didn't just tell them the answer. And I'm like, wow, you realize that people that answer your question on Stack Overflow aren't getting paid, right? There's no money involved in this. You're not paying for this answer. And you're like, they give you something better than just telling you how to do it. They're giving you, here's where that information came from. I also did a video on PackPub, this is JavaScript for mobile, which is what Ionic is. So Ionic hybrid applications, blah, 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 commercial over. Everything that I'm going to show you today is online. There's the link to both the code and the slides. Does anybody want to take a picture of that in case if you're like me, my memory is good for about 7 items. Once I get 7, I can't remember anything else without forgetting something. So I either take pictures or take notes. The link to the slides is on the session material right now. Hey, I'm actually on board today. I realized that part of the problem that I was doing when I come to these talks is I gave too many talks. I said, you know what? I'm going to do one talk, but do it well. Hopefully. You'll be the judge. Okay, a lot of the ideas that I've got here is from a really good book that I'm not even sure exactly how I came across it, but I have, the Amazon Prime, and I was doing a search for books on functional programming, and I came across this one. It's one of those books that costs like $6 on Amazon. And if you have Amazon Prime or the Amazon Prime Book Club thing, whatever it's called, I'm a terrible commercial spokesman for Amazon. It's free to rent. But it's called The Magical World of Functional Programming. It's by K. Anand Kumar. And it's got a lot of good ideas in it. It needs a little bit more editing, but the code and the way that he presents it is actually really good. And I enjoyed the book. And it's actually a 2-part book, but this ideas is only in the first book.
I believe the microphone does work.
The problem is that I can't do a talk like this. And things around here, I can do it a little bit like this, but I can't do this with my hands, because there's going to be a point where this is a programming session, and I'm going to do some programming, and I need my hands for that. Okay, let's at least go through the beginning part with the microphone on. Okay, so our agenda today. We're going to talk a little bit about what's wrong with object-oriented programming. For all of you boys and girls that didn't realize that, hey, there was programming before object-oriented programming. There was. I used to do it, and I liked it way better than what we do now. So I am going to at least a little bit bash on object-oriented programming. I'm going to do a little bit of background about what functional programming is and what goes into it. We're going to take a look at some functional code samples, and then we're all going to take a job interview. There is this thing called fizz. Fizz is just a sample idea, that's something that you might get when you go to a job interview and they say, hey, can you just whiteboard this for us? And so you would be on the board and you would solve the fizz program, just whiteboarding it out. And we're going to do that. And we're going to do it first imperatively, just using regular old JavaScript. And then we're going to go crazy and step by step make it more functional, just using JavaScript. Now, the important thing to understand here is I'm not going to use any libraries. There's a lot of JavaScript functional libraries that exist out there. I'm not going to use any of those, though. Oop. I'm just going to leave this up here and let you read it yourself. It pretty much sums up the way that I feel about a lot of the programming that I do today and the problems that I encounter, that there's definitely something wrong. Okay, I'm sorry, I can't keep holding this microphone. Okay, so JavaScript. Like it or not, it's one of the most popular languages in the world. It is the language of the web. There's nothing we can do about that. And believe me, if you were around in the 90s, you'll remember that there were lots of attempts to make it something else. There was VB script. There were Java applets. There were all kinds of other people that wanted to make something else take the place of JavaScript. And unfortunately for them, JavaScript won. There was an actual battle that went on. It raged for a couple of years, and when it was over, JavaScript survived, and it is the language not just of the web now, but pretty much it's all over the place. So it's moved from both the web to the server to mobile applications to programming databases like CouchDB and MongoDB. It's all over the place. But the problem with it is that it was never meant to do the things that it's doing now. It was supposed to be just a way to add some dynamicness to web pages. It was never intended to be this full-on solution. It was not intended to be like a Java or a C# or a C++ even, to be this application language that could span all over the place. It's difficult to debug. It's difficult to make really big apps. It's even tougher to make reusable code. And like it or not, it was never intended to be an object-oriented language. So the question I ask is, maybe we're doing it wrong. Maybe we're trying to wedge something in. I don't know how many people here remember the Microsoft Ajax library? How'd you like it? So Microsoft used to have this thing called the Microsoft Ajax library. It was an interesting solution to a problem that its biggest fault was that it was really big compared to what it was doing. And what they were trying to do is basically make a C# light for the browser using JavaScript and have it do a whole bunch of other stuff, including, Ajax was one of the things that it could do, which is always weird that they called it the Ajax library because you can do Ajax without their library, but that's a whole other thing. So the question is, what was JavaScript really intended for? What was the purpose? And the actual answer is that when Brendan and I started writing JavaScript in the famous 10 days that it took him to develop it, he was actually trying to do a light version of Scheme for the browser. So a lot of the features that JavaScript has are coming from the functional world of things. And unfortunately for us, when Netscape teamed up with Sun, and for all the kids in the audience, there used to be a company called Netscape. They were like the first big browser company, the first big company of the web, until they decided to do battle with Microsoft. and Microsoft, you know, did away with them. And they teamed up with another company called Sun. And God knows what happened to them too. They also decided to go after Microsoft and to eat some of Microsoft's lunch, and they don't exist anymore either. They got bought by Oracle. But the problem was that they said, well, this is like 1995. During this time, Java was just coming out. It was going to be the language of everywhere. And so the original name for JavaScript was LiveScript. They had the live server, they had LiveScript, and in order to get Sun on board with them, because Sun had more money than they did, and they were hoping that with Sun's hardware, their software, we could all team up and wrest some of the world from Microsoft. So they changed the name and they called it JavaScript instead, because they wanted people to think that it was a light version of Java for the browser. It's not, but that's what they wanted people to think. It was an actual intentional marketing decision, and part of the reason why you don't let marketers, tamper with engineering. So Scheme was a Lisp, and Lisp is one of the oldest languages around. Scheme is one of the two principal dialects of it. It's been around for quite some time. In fact, it was the second big language, and it still exists today. Lisp still exists. It's just not, doing as well compared to, mainstream languages. It's mostly still used by academics, but it came out in 1958. And Lisp was remarkable when it came out. I mean, just a freaking amazing language. I mean, this is 1960. They had recursive functions, dynamic memory allocation, garbage collection, macros, lexical closures. Most of this stuff, Java started off and had dynamic memory allocation and garbage collection, but it didn't have recursive functions, still doesn't have macros, just now getting some, I don't think it has lexical closure yet, but what a big thing now. Oh, we've got recursive functions. And you're like, but other languages have had this for 50-something years now, so it's not that impressive that you're just now adding it. And C# is also moving that same way. Most of the languages today, the new features that they're adding that they think are big and that they're touting are all functional based. Link in C# uses functional style of coding as opposed to regular imperative stuff. So what is functional programming? Functional programming isn't just you can't just say, hey, that's a functional language, that's not a functional language. It just there's some features that a language has to have in order to be considered functional. It has to have pure functions, and I'll get into the definitions of what each of these means in just a second. Pure functions, high class, high order functions, immutable data, recursion, and referential transparency. That's my word that I like to say. I just like that, my phrase that I love to say, because it just makes me sound smarter. I have no idea what it means. Just kidding, but it definitely makes me sound smarter by saying it. So, here's some of the things where functional versus imperative. And imperative is basically your object-oriented languages, your languages like C, and it's basically languages where you say, hey, here's how you do this thing, and you have to lay it out step by step of, hey, we're going to take an integer, call it I, and we're going to set I to 0, and we're going to do this with I, and we're going to put I into a loop until it gets to 10, and when, each time we go through the loop, we're going to get the value of I, and you're going to do all these things like that. A functional language will have as its primary construct, and I know this sounds so pedantic, and I hate saying it, but it's functions. You don't need objects to have functions in a functional language. The functions exist by themselves and for themselves. Whereas in a lot of and in this case I'm really speaking to object-oriented languages. It's an instance of a class is the primary construct. In order to do anything in C# or in Java, you have to have at least one class, one object instance of that class, and then you have like your main function, and you can do stuff on that. In imperative languages, variables exist. They exist in the plenty. They're constantly changing state. And one of the ideas in functional programming is that, Having variables with changeable state is bad. How many bugs do we have that are related to we didn't think that that value would be, that variable would have that value in it at that time, and that's what caused the thing to break. And so in a functional language, we'll say that state change is bad. Now, some of them allow you to do it because there are certain things you can't do easily without state change, such as how do you get input from the user? If you're not allowed to change the state of a variable, some kind of a way to get that in, it's going to be really difficult to write a program, but not impossible. The order of execution in a functional language is also something that we don't dwell on. We just say, hey, these are the things we want to have done, but the exactness of when they get done, for the most part, does not matter. And if you think you can't write a program like that, if you write SQL, for instance, you don't know exactly how SQL executes everything. You're just telling it the things that you want it to execute, and you're telling it, hey, join this table with this table, grab this variable, do this, and seek out this thing, and it just does it, but it's not doing it the way that we do imperative programming. It's not going, I equals this, do this, do this. It doesn't really matter. Also, flow control. In a functional language, we don't have a lot of if-then-else branches in most functional languages. We also concentrate more on, instead of having loops, we do recursion. And there's a beauty to recursion that a lot of times people don't appreciate. Recursion says, look, I can take this problem, divide it, keep on factoring it down till I can just do it one time on one instance, and then scale that instance up, as opposed to thinking in terms of loops. Instead, I break a problem down into, hey, can I do it this one time on this one thing? Okay, well, now can I do it if it's x plus 1, x plus 2, whatever. And here's just a few languages and kind of where they fall on the scale. And like I said, it really is a scale, because a lot of languages now, like Swift, Kotlin, C#, you can pretty much program those now in a functional style if you wanted to, because they have enough stuff in them now that you can do a lot of functional stuff in there. Likewise, you've got stuff like JavaScript, which is sort of like in the middle. And then on the far right side, left side, you're going to have languages like Haskell, Lisp, ML, Clojure. And Haskell, I kind of bold printed it because Haskell B. Curry is kind of a hero of mine. He's a guy who was a mathematician and logician, and he died back in 2006 or something like that. But either way, he has not one, not two, but 3 different computer languages named after him. Haskell, which is a functional language. There's Brook, which is his middle name, Haskell B. Curry, which is it's sort of a spin-off on C, on regular C that has parallel data on it. And then there's also a language called Curry. So this is how important this guy is to this whole field, that he's got 3 different languages named after him, plus the process of currying, which is something that you do in functional languages, is also named after him. You do it in both functional languages and math. Okay, so let's kind of, I'm going to even move a little bit faster. So a pure function. A pure function must return a value. It cannot produce any side effects. By side effects, it means that you can't like have it call this function and then some global variable gets changed every time this function gets called. It has to be self-contained. It also cannot rely on anything from outside of it. So you can't have anything influence it other than what's inside the function itself. And the most important thing is, regardless of when you call it, if you give it the same value, it should give you the same output. Now, I know that sounds like, well, wouldn't you want to do that with every function? But obviously we don't. And there's lots of pretty good side effects from doing this, if you do it this way, is that your functions become cacheable. I just told you that if I give you the value 52 and you return to me the value 96, every time I give you 52, you're going to give me 96. I can now cache that value. That's a process called memoization. It also makes it really portable. Because it doesn't rely on anything, I can move this from one computer to another system. I can put it on the web, I can put it on the cloud. I can also make it so my code is self-documenting. It's all right here. You don't have to look all over the library or this nest of code to figure out what this one function does, because everything it does is in the function. Makes it very testable, very easy to unit test a functional function. Because guess what? I give it a value, it's going to give me the return value every time. And it just makes things much more reasonable. First class functions, this just means that functions are treated like data. So I can pass a function to another function. I can return a function from a function. I can take a function, store it in an array with a bunch of other functions. I can create functions on the fly. And higher order functions, pretty much the same thing. It's just that you can accept other functions as parameters, return them. You can create functions that create other functions. And this is sort of the core of what the curry function is in functional languages. I'm not going to go that deep to explain that though. Guys okay? Everybody with me so far? All right. So just some real quick examples. So I couldn't imagine a more simple test. Here's just a function called pure. It's just going to check to see what your age is. And if your age is greater than or equal to 21, it'll return true. Otherwise, it returns false. And when I say that this is a pure function, it doesn't rely on anything else. It's not dependent upon anything else. And every day of the year, every month of the week, whatever, it's going to return me that same value of true or false for the given inputs that I pass to it. Here's where things get a little bit more difficult, and I apologize for putting this like as the second slide on this type. This is what's called a partial application. So what a partial application is it's when you have a function that requires, like, say, 2 parameters, but you only give it 1, and you give it the ability to get the other one later. So, and this is the part where I've got to pop out over here. So what's going on here is that we have this function that's going to create other functions for us. And so the thing that we notice that we're doing is down in here, we're returning n plus n. But we only give it an x here, and here's where the n is. You notice that the return from this function, add in, is another function. So when it says return function, it's not returning the results of the function call. It is returning the function itself. And now it has one of its parameters, and you can pass it the second value. And so it's creating like these add functions. So that if I say add in with a 10, call it add 10. When I call add 10 down here with 1, it's going to return 11. When I call add 50 with 1, pass a 1 here, it's going to return 51. It's a very simple example, but it's a very powerful concept. So the other thing that goes on a lot inside of functional programming is what's called compositions. Composition just means that, hey, I can take 1, 2, 3, out to n functions, combine them together, and have them work, become one function that I need to do something else. So in this case, real simple example, I'm getting passed in here 2 functions, f and g. How many people just went back to algebra? Just had that flashback, 7th grade algebra. And so all I'm going to do here is I'm going to return a function called x, or a function that accepts a parameter x, that's going to first call g of x, then call f of x, and that's all the function does. I won't go too much more mathy than that. Okay, so recursion just is something that allows functional languages to do looping. Now, there is a problem with recursion, and JavaScript has a problem. ES 2015 was supposed to have fixed it, but it didn't. It's what's called, when you do recursion, usually the language or the environment that you're in likes to preserve the stack frame every time you make a call in. And the problem is if you do too much nesting, all this stack frames start to build up, and your stack explodes. Now, there is a technique in functional languages called tail call recursion, where what's going on, or actually tail call optimization, what goes on is if the call to the new function is the last call in your function, it can actually do a shortcut and not preserve the stack frame because there's no need to. And ES6 is supposed to have had that in there, but so far I'm aware of no one except for Safari on the Mac that has actually made it work. Everybody else, they still haven't done it yet. Chrome has it in like a test mode because they found a bug in it, and that's why they haven't turned it all the way on yet. And who knows, maybe even now they fix it and I just haven't been keeping up to date. So here, for instance, here's a way that we can do, we're going to make a function that does a loop, and it's just going to print the numbers from 1 to 100. And you notice that what we're doing is here, we just say from and to, we spit out the number, and then we check to see if the from number equals the to number. If it doesn't, we call print numbers again, this time with from plus 1, and we call back in. So we're looping through this without a loop, just by doing recursion. Okay, so we're going to do a job interview. This is a pretty standard kind of thing that you might run into at a job interview where they say, hey, we want you to write a program that's going to print the numbers from 1 to 100. And if the number is divisible by 3, you're going to say print the word fizz by it. If the number is divisible by 5, you're going to print the word buzz by it. And if it is divisible by both 3 and 5, you're going to print fizzbuzz. So this is just a very simple thing. And initially, we'll just do this, kind of the way that you do. Because, and when you're doing something in one of these tests in a job interview, it's not so much as important to be perfect, just to be able to get this thing going and, have something generate out like right away. So we're just going to do this in our standard kind of imperative way. We have, here's where the actual call is that kicks this thing off. We got this method called fizzbuzz. We're going to go, and this is ES 2015 in case anybody just had a JavaScript like hemorrhage in their brain. Hopefully it's not that much different, but it's going to go, let I equal 1. We're going to go I is less than or greater than or equal to 100. We're going to keep printing these values out. We're going to check the modulus of 3 to see if it's divisible by 3 to print fizz, and if so, we're going to do a check to see if it's divisible by 5 to print buzz. And our end result here so here's our code, fizzbuzz1. We're going to go 1, 2, 3, fizz, 4, 5, buzz, 6, fizz, 15. We get the fizz buzz because 15 is divisible by 3 and 5. Like I said, there's nothing tricky going on here. It's just a simple test. And surprisingly, I've had people in interviews have trouble with that. We either do this or we do another version of it. I work for a company called Kelly Blue Book, and we'll have you do, hey, take a string Kelly, another string blue, and another string book. It's an array of strings. Count the E's in there, and show it. And there are times where people just struggle with that. And I'm just like, okay. And they're like, well, can you do something easier? And I'm like, I don't think so. Okay, so that's our first little take on it. We just did that imperatively. But, we did some things a little weird here. In that, yeah, we got it to work, and it works quite well. But because of the way that we did this, it's going to have some issues in trying to grow. Like, what if, I don't know, fizzbuzz became the hottest thing on the internet? And if you don't believe that can happen, Pokemon became the hottest thing going around. I've seen people walking around all over the place, holding their phone, running into things, walking out in the street. And you're like, hey, watch out. And they're not paying attention to you. So, you never know. Fizzbuzz has just become the hottest thing ever, and we want to expand it. We want to make it so that we can do more things with Fizzbuzz without losing the fizzbuzziness of it all. That was marketing speak. See, I can pretend to be a marketing guy too. So here's some of the things that I would fault us on this. Okay, so we've got like this application here actually does like 4 different things. There's a part where it's generating numbers. There's a part where it's doing a test to see, hey, is this within our criteria for either fizz or for buzz? We're also assembling these numbers together because one of the things that you'll know that we have is we have, hey, it'll go 1 space fizz space buzz. And so we put that all together in a line, so that's our output thing. And it would be better, at least to me, as far as maintainability is concerned, if we could separate those concerns so that they're a little bit more clear. And so that's going to take us to fizz buzz 2. So here, what I've decided to do is say, first off, hey, we're going to have this controller. And the controller, the only thing it's concerned about is whether, printing out the numbers from 1 to 100 or whatever the range is. You notice now I've made it so that the range is a little bit more flexible. I just say from and to, and those values are being passed in. And then I say, okay, well, test the number, format the number, and then print the number out. So we've broken these down into 3 functions. Now, once again, I'm going to warn everybody. This is a thought experiment actualized. We're just taking this thought of mine and printing it out on paper and going for it. Because, obviously, if you were in a job interview and this was your first approach and you had to type it all in and you're doing it, they might start wondering why you're having such a trouble doing this looping, just simple loop thing. Why are you getting all fancy with it? And especially if they only gave you 10 minutes and it took you 30 minutes to type all that in, you might be like out of time without having a working sample. So be careful. So either way, we're going to have our test function. Now our test function, now we've just made it so that, hey, we've got testing whether it's fizz or buzz, and now we're pushing these into an array so that the number fizz, or excuse me, the string fizz and the string buzz, and these are all being stored in the retrieval value. Likewise, when we do the format, man, I am having trouble just going a little bit. Okay. Likewise, when we get ready to print this out, we're going to actually kind of loop through that array and turn it all into a string. That's all this guy is doing, is putting this into a string, and then this guy is printing it out. The end result is exactly the same as what we had before, only it's just a little bit clearer to read through. So this is fizz buzz 2, nothing's changed. So we did our separation of concerns. Yes, our program got bigger. It was like about 12 lines. Now it's like 36 lines. But it is easy to understand. The next thing that we're going to do is that there's a lot of methods that are in JavaScript that we are not using. What's really weird is that like these things come from ES5, which came out in 2009. And I've looked at a lot of people's posts. There are people, don't get me wrong, that use them. There are other people that always seem a little bit surprised because most of the books on JavaScript don't have, they were written before 2009, and so they don't have these methods in it. And so people just, they did a couple of tutorials, or they knew Java, or they came from C# or C++, and they missed these array methods. And what's nice about all of these array methods is that they take array as input, they spit out a completely new array as output, and there's, you can easily go back and forth and kind of test out like what you're doing and see what the version is. I do not like it when the array that I'm operating on changes because it's hard for me to keep mentally track of what happened. And instead, these methods do transformation or create new arrays and then spit the new values out, and it's a little bit easier to follow the flow of things, and it's a more functional way of doing things. So the top 3 ones are going to sound very familiar to you, because companies have made billions of dollars off of these concepts. The first is mapping. And all mapping says is that I'm going to take an array, and I'm going to generate an array of equal length, but I'm going to do some sort of transformation on each element in that array. So it may be something simple, like I'm just going to multiply each element in the array by 2, or it may be something way more complex, like I'm going to go through and I'm going to figure out the cosine and the tangent and this, and because I'm doing a, I don't know, a three-dimensional game or something. But either way, so here's the map function, and this is just going to take this array of numbers. We're going to map them to a new array where we're going to multiply each element in the array by 2. And so nums2 is exactly the same length as nums, except for instead of going 1, 2, 3, it's going to go 2, 4, 6, 8, 10, and so forth. The next one is filter. Map, filter. I wonder what the third one is. Filter just says, hey, we're going to run every element in this array over some kind of a test. And if it passes the test, we're going to put it into the new array. So in this case, we're going to say, hey, for every element that's in here, so we're going to take nums again. If it is divisible by 2, we're going to put it into our new array, nums3. That's all we're doing. So filter is going to have as many, less, or no elements in the array, depending on whether anybody passed the test. The final of the sort of the big three is reduce. And reduce takes an array and changes it into a scalar value, meaning it changes it into one thing. So this could be like you can use reduce to aggregate and add up the sum of something. You can do it as something that's going to concatenate a string. So I'm going to take a whole bunch of different parts of a string and concatenate them in the reduce so that I get one string as the output. And there's sort of two versions of it. There's the reduce, which is going to work from left to right. And there's also reduce right, which is going to work from right to left.
I have a quick question on this.
Sure.
So we're talking functional programming. When I see letters dot reduce, I'm going, boy, that sure looks like an object with a method.
Letters dot reduce. It's not an object in this case. In this case, it's a method of the type. So, which is yeah, I know, huh? I just sound like I just did some verbal ninja-ness. But in this case, because there's no object, I didn't create an object.
It's like a static function?
Well, it's an object of the type, meaning that I can do this on all the types that are of this type array, that are of arrays. I can do this method on all of them. But in order for it to be an object, I would have to at some place create an object, and I have not created an object. Yes, sir?
What's the output?
The production in this case is that I'm actually concatenating these strings together. So here what we're doing is we're going into letters, and I'm taking each one of these strings. These are actually individual strings, not characters. And I'm going to actually just concatenate them all together and put the output here.
So the first argument is it's the result of the previous run.
Right. Right. So yeah, previous, and you can also on reduce, you can give it an initial value, and that would go like comma here, and it could be like if you wanted to start at 100, or if you wanted to start with Troy is really cool, and then the other parts of the concatenation, you could do that, but you can also give it an initial value. Couple more. Every is just a tester. And it just says that all the elements of the array must pass this test. If any one of them fails it, the whole thing's considered failed, and it stops at that point. And so in this case, we're looking at this thing called jump. Now remember, in JavaScript, we can have arrays of mixed types. So we have in here numbers, we have a string, we have another number, we have an object. And so in this case, I'm going to go through here, and I'm going to say, is the type of element equal to number? And this has to be true for all of them. Because it is not, is every numbers is going to be false. ForEach I just throw in here, but it's not actually a member of this set. And the reason is because it doesn't return an array. Whereas everybody else returns some kind of a value, this ForEach doesn't return anything. It doesn't return a single value, an array, or anything else. It returns nothing, but it's a looping mechanism that they screwed up on. When they designed ForEach, they forgot a small little thing. Usually in loops, you like to have a way to sometimes break out of them with like either break or to go to the beginning of them with continue, and break and continue don't work on those. So in ES6, they have another looping mechanism. They had to add another one specifically because they kind of screwed up on this one. So let's see how we actually have used this in our code. Oops. Okay, so now what we have here is, let me make this bigger. You notice now what I'm doing is, first off, I'm using some new stuff. I've got mapping in here, and so now I'm going to say, hey, I'm going to take each element, I'm going to run a test on it, I'm going to format the output of this, and I'm going to create a new array called results, and then I'm going to send results.forEach, and then just say print, so that it prints out all of these guys one by one. So we're doing it just a little bit differently. Array.from is probably one of my coolest friends out of, especially whenever I'm doing test data. Out of ES6, it just allows us to generate arrays. That's all that it does. And so in this case, what I'm saying is, I'm going to say, hey, take this thing with the length of from 2 minus from plus 1, so in this case 100, and then go through, iterate through each of the elements, adding plus 1 to it. And basically, I'm creating an array of 1 to 100 on the fly, dynamically. We also use the reduce method in here. So here we have inside our output, we're using reduce to concatenate the strings now. And that's all this guy is doing. Man, I've got to figure out why I can't seem to do that steadily. So it's just going to go through here and concatenate the strings for us. The output still just, right now it's just printing out whatever the value is. We call the controller with 1 to 100. As we were doing before. And so this right here just causes, it's just a slight improvement using a few more stuff in ES6 and ES5. Okay, so our test function has what I call a bad code smell. In that you can see that we're just testing this thing where we're saying, hey, we're doing the modulus operator 3, the modulus operator 5. Sometimes we print the word fizz, sometimes we print the word buzz. But other than that, the meat of it is actually the same. You have a test and you have a string that it's going to do a concatenation on. And so the question is, what happens if someday, hey, they say, well, if it says, if it's divisible by 7, we would like for it to say boop. You know, so you get fizz, buzz, and boop possibly. Right now, that would be really hard for us, well, not really hard for us to do, but it gets a little clumsy in the way that we would add it. So we're going to change things again in our sort of fourth chapter of this. Now what we're going to do is we're actually going to separate out the fizz and the buzz functions, just kind of an intermediate step. And what we're doing here is we're going to check the data against the number 5 or whatever, and we're going to push it the value that it returns onto here. And we can see right now that that's sort of problematic because these two functions right here and right here look nearly identical. And we'll fix that in the next round. But here we're just going to call the number now, the initialize, and now instead of just having one test, we actually have two, one for fizz and one for buzz. And the sort of the way that functional coding works and in the way that we're doing things here, everything's kind of like on this inside out sort of thing. That's how the code is read. So this initialize operation happens first, then the fizz operation happens, then the buzz operation happens. And you notice that now this is what our test is actually composed of, is these three functions. And initialize is just emptying out the array so that there's nothing in it except for the number, which number that we're calling. So this is what this guy does. And every time I've ever seen this in someone else's code, I was like, what is that? And then I finally realized, oh yeah, you're just creating an array. We're putting this value into an array, and so it's returning an array with just the number, for instance, 1, 2, 3, 4, or 5. One of that thing's going to be in there, and then it's going to add, if there's a fizz or a buzz, that to the array as well. Okay, so talked a little bit about array from, I'm not going to talk that much about it. It's kind of a cool function. It's really, really nice to have because it can do even more stuff than what I'm showing there. And I actually do use array from a lot. Usually it has to do with when I'm writing unit tests. But it's definitely very useful. And I'm going to skip one to get to the fun function factory. So in the 5th chapter of this thing, what we're going to do now is we're actually going to create functions that create other functions. And the actual technical term for this is partial applications. And it's actually a lot easier to look at than it is to try to explain. So we already said, hey, with this test maker, we knew that there was some repetition, and we wanted to eliminate the repetition in our code because we didn't want to have modulus 3, modulus 5, potentially a modulus 7, or whatever. Just keep adding these on where we have entire functions for this. And instead, now what we're going to do is we've created a function called test maker, and we just pass it. Here is the actual test that it's going to execute. Here is the string value that it's going to append to it. Now, what's nice about doing it this way is that when we do it like this, it doesn't care what the test is. We can put, it doesn't have to be an X modulus something. It could be any other thing we want to test. So when we take a look at test maker, here it is. You notice that we pass in a condition. We pass in the string when it is true. Then it returns a function, and the function is going to take into it this tuple, and the tuple is just an array that's holding the data. It's going to test the condition with the current value of the tuple, and then if it is true, it is going to push onto the tuple the when true string. Now this gets kind of a little abstracty because now you have a test itself is being passed in as a value. A small little function that does that test called condition is being passed in, and also the string is being passed in. And the results of this is just put into this test maker thing, and that's what's getting added to the fizz and the buzz now down here. So when we have the fizz and the buzz, these are functions now that have been created using the test maker. Okay. And just to make sure that you guys don't think I have something up my sleeve, let us change this guy to here and get rid of that guy. And so here is the 5th version of this thing. Once again, everything's still working. Our fizz and the buzz keeps going on about its duty. So let us continue. So now we're going to just move things up even one more level of abstraction. The way that I tend to explain functional programming to people is that anybody else here do either C programming, and I'm not saying C++, I mean just C or assembly, or it has to do with levels of abstraction. I mean, because sometimes people think assembly is really, really hard. It isn't. It's just really, really a pain in the butt because every little thing you want to do, you pretty much have to either do yourself or you have to have a library that already does it. Even simple things like putting something to the screen. So you have to keep building stuff up. And so when you go into a actual commercial language like C from assembly, you move up a level of abstraction because there's a bunch of stuff that you didn't need to do that the machine could do much better and equally as fast, if not faster than you. So you move up that level of abstraction. When you go from C to, say, Java or C#, and I'm skipping C++ intentionally because there were so many things that we got wrong in C++ and object-oriented stuff, especially templates, where you magically make your code 5 times bigger. But you move up another level of abstraction, meaning that the language starts doing even more stuff for you. And you're still coding, but you're not having to dig down in the dirt to do stuff. Anybody that's ever done, like, DOS programming back in the days before Windows, where you're actually having to do everything yourself, knows that, man, putting a button on the screen is way easier than doing the crap that I had to do. And then functional programming kind of moves you up one more level of abstraction in that it says, now it's a little harder with JavaScript because it's not, it's like I said, it's in that middle ground of functionalness. It's not like a closure or a F sharp or Haskell where it's got all this other stuff in, but it can do all this mapping and reducing and a lot more functions like that, like probably a few dozen operations like that, all done on lists of stuff. Because it's very rare in coding where you really only want to do something one time. So let's take a look at what we've got on chapter 6. Okay, so we have the test maker as we've already shown before. We haven't done anything else to him. Now, the question is, well, what if we wanted to add a bang? And a bang function is going to print itself out when it's divisible by 7. Look how easy now that becomes. All we have to do is just say, hey, test maker, if this thing is divisible by 7, it's going to be a bang, and then we add the bang to the end of this operation. Likewise, I could add other things. And what's nice about this is that my code is actually kind of self-documenting itself. Yes, I put some comments in there just to explain things during these presentations, but if you were to read this, you'd go, oh, okay, it's taking the number, and it's going to do an initialize, it's going to do a fizz, it's going to do a buzz, and then it's going to do the bang test on it, and then that's all of the stuff for my test function. This is actually a function here. And then what we're doing, if we take a look at the controller here, so here, we're going to map all these guys out by calling once we do this on test, we're going to map this out with the format output, and then we're going to do the print on all these. What's kind of interesting here is that even though this is still kind of moving down, in a normal step-by-step imperative way, there's a point where you kind of go, you forget that these are actual arrays and that it's doing loops and stuff over it. It's just, hey, it's doing this operation, this test on this stuff. And especially in really good functional languages, they also do what's called lazy loading of things. And so what they'll do is, like, say I was doing this from 1 to 1,000,000. Well, if I was just going to create an array of 1 to 1,000,000, there's a chance that I might actually run out of memory, or that it might be just excruciatingly slow. And instead, what functional language will do, they'll actually subdivide it out. If you've ever, even on a link query in C#, if you've ever had something that's really big, you'll notice that what it does is it does a few of them and then some more, and it keeps doing them. But if you tried to do like a to list on it, suddenly it's got to do the whole thing, and you've just forced it to not do lazy evaluation. But either way, so we've kind of moved up one more, and we're using all of our little functionalness. And so the question starts to become, well, when do we stop with this, Troy? At what point will you be satisfied? So the kind of like the getting close to the penultimate here, our next thing that we're going to talk about is composition. We're going to actually put composition to use. And then remember, what I said was composition is where you combine one or two functions, two or more functions together to combine them to do one thing, and basically you create a new function out of those. So we're going to combine our test and format functions together. So first thing that we did was we created a compose function, and all it does is exactly like it showed in the slide. It's just going to take a function 1 and a function 2 and then combine them together so that it's going to run whatever the argument is. It's going to run it first on function 1, then it's going to run it on function 2 and return that results out. And then in here you see we do the actual composition of the test function and format function. So we're combining these two guys together. We're going to call that map function. Yeah, I should have thought of it. This is why I actually do need a marketing person to think of names for me, because I call things stuff, and then later on I go, yeah, but that might get confused with the map, and it doesn't actually have anything to do with the map. But either way, we're going to map over this function And we've just created a new function called mapfunc that's going to do that stuff for us instead of going first the test and then the format. Again, now we have the bang still in here, and let's just really quickly show that this is still working. That's 7. So here's our FizzBuzz number 7. Everything's working. We can see that on 7s we get bangs. So on 7, on 14, and on 105 they all come together and we get a FizzBuzz and a bang. Okay, so there's a question here where you have to always ask yourself, you know, are we done yet? How much further do you want to take this? And I truly and firmly believe in just pushing the limits for absolutely no reason. Keep doing it till it breaks. Just find out. So let's see where we've got right now with tests. Our FizzBuzz number 8. So with number 8, all we're doing now is we're just kind of cleaning things up. We've even made a controller maker. So with the controller maker, it actually makes the controller for us. So I'm passing in the test function, the format function, and the output function. And then it creates a function called controller maker, which takes from and to. So like I said, this can start getting crazy. So now we have something that's going to test those guys out, and all I do now is I just say, hey, controller maker, here's your test function, here's your format function, here's your print function. We're going to call this function FizzBuzz, and we're going to call FizzBuzz function with the numbers 1, and 106. That's our range that we're going to print this stuff out. And so it's just going to go through here, iterate through all of this stuff on the test maker. We've even added a boop function in here just to show how easy it is. Again, all it's doing is it's calling each of these functions sequentially, initialize. I probably should have used a compose on this guy too, fizz and buzz, and then it's calling those guys all out. It all still works. So if we go back here, comment this guy out, and we comment this guy in. And now we can see that we've got FizzBuzz 8. On 11, it's going to print boop. On 7s, it's going to print bang. So we'll see boop on 22. And we just see all of them kind of doing their thing. I don't know what number it would be that they all come together. But if we were smart, if I was smart, I would have stopped right there. I would have said, okay, this is probably about as far as I should go with this. This is starting to get a little... the thing that's bad and nice. So, like I said, I'm doing all of this in just plain JavaScript. There's no libraries as such, but there are libraries that make the compose, the actual partial application generating, which is both partial applications, and another term for it is currying. They have all that stuff built in so that I wouldn't have to create the actual code for that. So that theoretically, like the test maker and the controller maker, I would just pass stuff to it, but I wouldn't have to actually have the code to do that stuff myself. But there always is a point where I go too far, and it's usually the point where I have to apologize. And luckily this time I don't have to apologize to anybody. And here we're going to go way too far. One of the things that you kind of want to avoid in a lot of functional languages, you want to kind of avoid that whole idea of disposable variables. And this is, I'm creating a variable and then I'm just passing it to something else. Because you could just do the pass instead of doing it. And so we end up with this, and you can tell by the fact that it starts off here, and all I did now is I got rid of all of the code that I didn't really need to generate, at least as far as the test maker stuff, and just pass the actual function into it. So you notice instead of creating a fizz or a buzz variable, I'm just passing the test for that code into a function. And you notice this is incredibly hard to read. Not to mention it goes on for just way too long. And so that was probably the point. And then the other thing that I did was because the thing that comes back from the controller maker is a function, I can actually just call that function. I don't actually have to store it anywhere. I can just call it, and that's why you have the parentheses right here, is I'm taking the function that gets returned by this and now just calling it. And that kind of gets us to our step too far, because this is actually hard to read, and that's a very long line of code. Unfortunately, a lot of functional languages, while they're not on a single line, usually what you'll see is you'll see them broken up into different sets of parens, and that makes it kind of hard sometimes for people to read, because we're used to seeing the curly braces and then kind of doing a top to bottom scan with our eyes. And when you have to do a functional language, what you usually have to do is start with the inner set of parentheses and work your way out. And that one little bit right there probably screws up more people, more smart, healthy people than anything else, is because you have to go from the inside to the outside instead of from the top to the bottom. Okay, let's wrap this up then. So we know we went too far. It was probably way too far. As I said, that their partial applications, compose, other functional constructs should actually be part of the language. They're not part of JavaScript. That's why I don't include JavaScript as a functional language, because those things aren't in there. But there are a bunch of libraries to do this stuff with. And so there's _JS, there's Lodash, which is _ slightly improved. There's Ramda, which of all the ones is the one that I actually kind of like the best, and I think the version number is way up by now, because I haven't used it in a while. And then there's just functional JS, which is a library, FNJS, which also has this stuff in it. And what that does is it saves you from doing that grunt work that I did. But I always like to know how the grunt work is done, because I don't believe in magic. So for resources, here's a link to the book, The Magical World of Functional Programming. There's another book, and this book is the one that if you want to be a remarkably better programmer from just reading one book, the one book that I would recommend is called The Structured Interpretation of Computer Programming. It is the book that MIT computer science students are given to read. It's in Lisp or Scheme. But if you can actually get yourself through that book, I guarantee you will be an order of magnitude better coder than you are right now, no matter how good you are right now, because it will test your brain, and the stuff that you will learn in there will change how you code every other language. So there's a link to the FizzBuzz test. There's also a thing to Kangex, and Kangex is just a site that lets you see where ES6 and actually now ES 2015 and ES 2016, where they're supported at. I highly recommend, hey, just go ahead, download the code, tweak around with it, play with it. It's all up online on my GitHub. Download it. Read The Magical World of Functional Programming. It's a short book. It's like 70 pages, but it will open your eyes a little bit. The other one, The Structured Interpretation of Computer Programming, that link is the book. It's actually to the book itself. It's online for free. It's not stolen. So if you have any sort of ethical qualms, I appreciate that, but it is not stolen.